My friends in Brazil, and good evening to all my colleagues in India. I have a great pleasure in welcoming our esteemed speaker today, Dr. Julia Soares, and let me introduce her. I first of all welcome you on the behalf of all the members of the Bovine Embryo Transfer Group. Julia, she holds a degree in veterinary medicine and master's in animal science. She is doctorate in animal reproduction from University of Sao Paulo with a sandwich period of the University of Sydney, Australia. She has experience in the field of biotechnology applied to the reproduction of bovine and buffalo with emphasis on the control of follicular development and ovulation. She did her postdoctorate from Federal University of Sao Paulo, Brazil. And I was lucky to meet her personally in year 2019 when I visited Brazil to attend the annual meeting of the Society of the Embryo Transfer of the Brazil. So that time I had went to their farm, a Murra farm, which is around 200 kilometers from Sao Paulo, and I'd spent the whole day along with me. My another colleague who was with the JK Trust, Dr. Vinod Patil, was also there. And we observed a lot of OPU and things over there. And we got some clues from Lucia. And when we returned back to India, immediately we took a trial on the Murra buffaloes at the doorstep of the farm, and we could succeed it. Now, we have also honored with the presence of two of the the director of the Central Institute for Buffalo Research, as you know, which is there at ISAR. One is the ex-director and one is the current director. We're really honored with the presence of both of them, our senior member in our bovine embryo transfer group. First of all, let me introduce Dr. Indrajit Singh. Dr. Indrajit Singh is a distinguished researcher, academician, and educational administrator, and who is heading the Guru Angad Dev Veterinary and Animal Science University, known commonly as a Gadwasu, Ludhiana, as a Vice Chancellor since 2020. And earlier to that, he worked as a Director of Animal Husbandry, Punjab, for over 1.5 years. And prior to that, he provided his services on ICR's Central Institute for Research on Buffaloes at Hisar in Haryana. Dr. Singh did his doctorate in animal reproduction from University of Liverpool, United Kingdom, and then he is also a recipient of many national and international awards. He has been the president and vice president, as well as the general secretary of the Asian Buffalo Association during various periods. For his enormous contribution in buffalo research and development, he is popularly known as Murra Man. Now, let me introduce our another guest, Dr. T.K. Datta. Dr. Datta, after his graduate studies and master's and doctorate, then he had his postdoctoral research at the University of Laval, Canada, and Michigan State University, United States. Over the period of almost 30 years, he remained deeply involved in the research, basically oriented towards reproductive biology of the farm animals, and also for the in the new avenues. He has pioneered the work on oocyte and embryo genomics in India. He holds the position of currently holds the position of the director of Central Institute for Research in Buffaloes at Hisar in Haryana. Dr. Datta remains the recipient of several awards. Most prominent ones, he has also mentored more than 30 masters and doctorate students and published more than 100 research papers. He is widely traveled all across the world. I also would like to introduce the core committee members. Julia, the government of India has recently constituted a core committee for looking after the IVF labs of the country. We have about 30 IVF labs which are funded by government of India, and then we have got about 8 private labs also. So this core committee, presently I am heading this core committee, and I have another 5 colleagues who are with me. One is Dr. Siddharth, like Dr. Siddharth, you can say hello. And Siddharth is working with the National Dairy Development Board as a manager of the IVF lab over there. Then we have a Dr. Sanjeev Chaubal, who has joined us from United States. He is working for a very well-known organization known as Transova Genetics and managing one of their lab. I don't know whether we have third colleague of ours. I think he is not yet joined, Dr. Ajay Aswal, who is heading a lab, IVF lab, and doing very good work at Uttarakhand Livestock Development Board. Then we have one Dr. Mutharao, who is heading the lab in South India at a place known as Guntur. And the fifth one, we have one Dr. Amol Sahare. He is working for a private lab again into South India. With this introduction, without taking much time, and now I request Dr. Julia to proceed with her presentation, please. Over to you, Dr. Julia.
Thank you, Dr. Zauer. Thank you very much. Thank you for inviting me. I thank you, first of all, to all of you to be here in this Saturday. I know that's hard. You could be now spending time with your families. I know that in India it's evening, and even in countries that's not evening, it's Saturday. So I thank you for be here and that we can talk a little bit about IVF in Buffalo. I hope you all and your families are well, first of all, because we are in pandemic time. So I really hope you are well and your families are safe. And thank you, Dr. Zauer, for inviting me. It's a great pleasure. Dr. Zauer was here in Brazil with us. He worked with us with IVF, and we changed experiences here, and we're very, very grateful for all of us. Thank you very much. So now I'm still working with reproduction, and we are making some experiments with using stem cells for reproduction, and we are having interesting results. But now, today, we will talk about especially about the IVF procedures and the results and our experience here in Brazil, mainly in our research group with Nelson Carvalho and Professor Pietro Barzelli, that we worked together for a long time. So let's start with the presentation. And is that okay for you?
Yeah.
Okay, so we'll talk about the IVF in buffaloes. And in the last 10 years, the growth rate of buffalo herd in the world was about 19%. We know that it increases the milk production in about 37%.
You can share your presentation. Sorry, Julia, you can share your presentation.
Oh, it's not sharing?
No, not yet.
You're not seeing.
Okay. Okay, let's do it. I'm sorry, now?
Yes, good. Yes.
Now it's okay?
Yes, perfect.
Okay, sorry. Okay. And the milk production increased, and we are talking about today 200 million herds of buffaloes in the world, and the annual production is about more than 100 million tons of milk. In Brazil, this reality is about a growth of 19% of the bovine herd. In currency, the census says more than 1 million heads, but we know that we have more than 3 millions because there are regions in the country that we can't count the animals. And what we want to say is that this is a very interesting activity around the world. And it's animal of production, so we can explore the buffalo much more than we are doing actually. So we know that buffalo is the selection of these animals for milk production. In Brazil, we have some dairy, some milk productions of this herd, and we are increasing the genetics of these animals to produce more, of course. And we have the destination of these buffalo milks. It's very strong here in our country, and it's very appreciated as well. And in many other regions of the world, we know that. And doing the most interesting thing is that doing the comparative between buffalo milk and bovine milk is the characteristics of this milk. For example, more proteins, more calcium, more phosphorus, less cholesterol, and more dry matter. That is very important for milk cheese production. We know that this is the characteristic that you need for produce the lectins. And also, the buffalo milk has much more vitamins like A, D, B2, iron, magnesium, phosphorus, and potassium. So this is very, very rich food that we have in our hands, and we can explore the market using this material. We also can select for meat production. We know that maybe not in India, but it's used a lot here in Brazil and other parts of the world. So the meat is very interesting and of very good quality. So talking about the buffalo herd growth. For achieving this growth of the herd, we need to make the productivity control associated with the genetic improvement and also the reproduction biotechnologies. So this way we can explore more these species as a zootechnic animal. So which biotechnologies are we talking about? We have the timed artificial insemination that we work hard here in Brazil, mainly during the breeding season and the non-breeding season, that we know that buffalo has the characteristics or seasonality. So we have to work on this. The multiple ovulation and embryo transfer, also called by superovulation, and the in vitro embryo production or in vitro fertilization that we will talk today. And the embryo production in buffaloes, how is it occurs? First of all, how they are produced. They can be produced, as we talked, in vivo or in vitro. I will talk just a little bit about in vivo production because we just migrate or we just start to developing the in vitro production because of the results of the in vivo. So, talking about efficiency of these techniques, when we make a transferable of embryos, we have about 6 embryos per flushing when doing the superovulation. We consider a conception rate of 50%, and then in the end, we will achieve about 3 pregnancies per flushing. But when we are using when we have 2 transferable embryo per flushing and considering a conception rate of 30%, we have less than 1 pregnancy per flushing when we're talking about buffalo. This we are making a comparison in buffalo and cattle or bovine. And what we can see here is that the efficiency of this technique in buffalo is much less efficient than when you compare it to cattle. The last experiment we did with superovulation was especially using the PGF. We used the prostaglandin F12 during the periovulatory period to increase the fertilization rate in superovulated buffalo. That was our last approach to try to improve the embryo production. So our hypothesis was that when you superstimulate the ovary, we know that the big problem of the superovulation in buffaloes is that when we superovulate the ovary, some of the oocytes, they are loosed here. We lose the oocytes because we don't know what happens exactly. We don't know exactly what happens that the fimbria, they can't captate all the oocytes into the uterus. So we want to increase this recovery rate and not lost the oocytes. So we use the PGF by injection or using osmotic pumps. And we tried to increase the fimbria activity and the ciliary bit to capture all the oocytes and not lose them. The protocol is this one. We can find and see better with the paper. And we know that the protocol of superovulation is a little bit long. We have many administrations of FSH. And here we did the PGF, and the protocol was similar for all the groups. The only difference was the administration of the prostaglandin. So in the harvest of the embryos, what we saw, mainly the main results were that the fertilization rate was better when we used the prostaglandin, and the total embryonic structures did not differ. So we saw an improvement in the fertilization rate, improvement in maybe a little bit in blastocyst quality, like you can see here, but the total embryonic structures, it keep them the same. It was not increased, as you can see better in this graph here. What you can see is that the number total of embryos recovered and produced, we can see 2.1, 1.7, 1.6. It's a very, very low number. You know, this is not the essential that you want to apply biotechnology. So we have to work hard to increase these numbers and make this technology available. According to these results, the superovulation, we tried to make different approach using the in vitro production, obviously based mainly on the results that we had in bovine, mainly in Nelore in Brazil. We got a lot of Nelore cows, and the production of Nelore is amazing, it's great. So of course the follicular production and all the follicular dynamics in the ovary is completely different in buffalo, but as researcher and working with applied science, we want to increase our results and make it better to be applied in the field. So talking a little bit about the evolution in vitro, I think maybe Pietro talked a little bit about it in his lecture. He likes to show this data. The evolution of in vitro marketing in Brazil, we can see that we had an increase and huge increase of this technology. This is mainly because of the Nelore cattle, and the superovulation, we did not increase it exactly because of the results that we found. I'm not saying that this technique doesn't work, but if this is bad, but comparing to in vitro, it's completely different. So we verified an increase of more than 300% of the production of embryos using this biotechnology. Especially in Brazilian embryo transfer market, we saw again that the embryo production, it is the great choice of the producer and the researchers because exactly of these numbers. Now in Brazil, about 90% of the embryos produced here are from IVF, and the opposite 10% are from superovulation. So I will talk in the end of the lecture of this conversation, better talking about the embryo transfer. When you got large number of embryos, even if you don't have a large number of embryos, we always have to think about the recipients, because these embryos have to be transferred. So we got to think about it too, and the protocols and the approach to improve this category as well. So this is a slide from Professor Sartori here in Brazil. It's just showing our participation in the in vitro global market. Today, Brazil got about 60% of the world production of embryos, increased almost 30 times. And this is mainly because of, like I said, because of our beef cattle, especially Nelore cattle. They produce a lot of oocytes. So we proportionally, we have a lot of embryos produced in vitro. I think probably Ieda talked about it in her lecture. Talking now directly about the technique, uh, the ovum pickup or follicular aspiration guided by ultrasound. I think that everybody here has the experience with this. Sorry, has the experience with this technique. And we know that in buffalo there are some particularities, some specialties that we can verify in this species. So the technique basically is the same. You know, we have to aspirate the oocytes to keep the follicles to keep the oocytes. And buffaloes who have the position of the ovaries a little bit different of cattle, and also the adherence of it and the size of this organ also is different. But nothing that avoids to execute, to perform this technique. After the same procedures, washing and selection of the oocytes, I'm sorry, it's in Portuguese, you know as well, it's just to illustrate the technique. And the next steps, the same from cattle, like maturation, fertilization, cultivation in vitro. The main difference here, I think Ieda talked a little about it. When we started the experiments in Brazil with IVF, we lose some experiments exactly because of this moment here, because the buffalo embryo is it's quite 36 hours faster in development comparing to bovine. So we have to check earlier the development of the embryos, especially in this phase of blastocysts. And this day 6, day 7, or and now here is day 5 in buffalo that we achieve the blastocysts. So if we don't pay attention, we will lose this phase, and the embryos will be hatched when we will check. So they are faster, and we have to pay attention about it when performing this technique. Sorry. This is just to illustrate the IVF buffalo calves in Brazil. The first ones in 2005. It is fine and was healthy, a healthy cow, and was a bull. And this is the same bull in adult phase. Initiating the studies with the in vitro production in buffalo, we always compared this technique and this species with cattle, with bovine, like I said previously. And making this comparison, we can do the ascertainance and the right approach for the species compared with the good results we had in cattle. So one of the first experiments was to evaluate the effect of follicular dominance on in vitro recovery rates and on in vitro oocyte competence in bubulus, in buffalo, and in cattle, in beef and Holstein. In this case, in Bos Indicus and Bos Taurus, it's Nelore and Holstein. Here, just to illustrate, we always perform at the same time, at the same management, the animals. And what we saw, one of the main difference when working with buffalo, that sometimes people get afraid and it can compromise the results, is the number of follicles present in the ovary of the buffaloes. Okay, here we can see the huge difference when you work with Nelore, with Bos Indicus. We have 42 visualized follicles and it's different in Holstein and Buffalo, 22:18. In general, we don't want to decorate numbers, specific numbers now. You just have to be in our minds that Buffalo, it's similar to Holstein. We are not similar. We're not working with a species similar to Bos Indicus. We are working with a species similar to Holstein. The results generally are very similar to Holstein. So even for visualized follicles, all sites recovered, cleavage embryos, and the blastocyst, we can see that it's lower when we compare to NLR, but it's similar when compared to Holstein. Sorry. And we can see that there is another characteristic that we are evaluating. This is from 2018, and we are seeing again, we're seeing again now that buffalo, we have another particularity. The distribution of all sites retrieved per OPU in Muha buffalo donor, we can see that it spreads a lot. We had a great dispersion of this distribution. And here we can see there are few animals with a great number of retriever oocytes. So most of animals are here. So this is our challenge. This is in what we have to work on and improve the results. The selection of one of the first studies know all these characteristics of buffalo physiology and endocrinology is that the hypothesis that we evaluated based again in bovine that we could do the selection of donors by antral follicular population. The hypothesis was that great antral follicular population animals with these characteristics, they got great AMH and also will have great in vitro embryo production results. So was performed this study with the same farm managed nutrition like we saw previously, and was verified again that this is Gyr, cattle, Holstein, and Muha. We can see that Gyr is different, statistically different from Holstein and Muha that are similar for anthrofollicular population and also for AMH. Here the dispersion, again, Muha is similar to Holstein when we evaluate the plasma anti-Müllerian concentration. And Gyr is different. You see Muha, Holstein, similar, and Gyr, the anthrofollicular population. Continues working with these variables. We always repeat in a different approach these results, and we saw here with Professor Pietro again that the AMH concentration, the correlation is positive of plasma anti-Müllerian concentrations, and the number of follicles aspirated, the number of oocytes, and the number of blastocyst producers. All of these results with AMH, they just want to tell us that we could, like they do in bovine, like we do, because we also work with cattle here, and we can use the AMH like endocrine marker for IVF. These animals can be selected by AMH for embryo production because we have this positive correlation between the AMH, the follicular antral population, oocytes recovered, and in vitro embryo production of buffalo. This study we performed some years ago, and we verified another characters. As we selected by AMH, we can also select by the number of follicles in the ovary. So we made a selection of animals And we have tertius, and we have animals with low follicular population, medium follicular population, and high follicular population. And what we saw? Mainly that animals with high follicular population, they got more viable oocytes and more inhibited oocytes. This is proportional, of course, but we verified more viable oocytes. However, the pregnancy rate did not increase in this area. Another thing that we verified was that the of probability of blastocysts per OPU was greater as the numbers of retrieved oocytes per OPU. But the probability of pregnancy and of blastocyst rate did not increase. So we had controversial results, but we saw that this selection at this moment in this study did not work. Another approach we did here was in a partnership with the group of Marcus Chiarazzi and Flavio Pereira. They worked hard with gene expression and did the reference gene selection for gene expression analysis of the oocytes collected from dairy cattle and buffaloes during winter and summer. Because we know that dairy cattle, they don't know the seasonality of buffaloes. That is because of the melatonin and all of that endocrine factor. But they are similar to buffalo in many aspects, mainly in summer and winter. And what we verified, we observed that in general, that the follicles, total oocytes, viable oocytes number and viable oocytes, the percentage, in winter, they are greater than in the summer, considering the reference genes. And especially in cows, this characteristic is stronger than in heifers. Knowing about all of these characteristics, uh, we started developing treatments to improve the in vitro embryo production in buffaloes. Because, as I said, we work with applied science and we want to improve all of these results to make this technology available and to make buffalo a species of hard and great production. One of the first studies, this is a sequence of studies to go to the last one that we did, that we have that we had and have now the best results. This is one of the first using the BST. The hypothesis was that using BST, we would increase the IGF levels and then increase the oocytes, the follicles in, growing and the oocytes recovery. So we evaluated the effect of recombinant BST on follicular population and on in vitro buffalo embryo production. And what was verified that even doing all these applications of BST, I won't enter in details of the study. We don't have time, and we can check at in the manuscript in the paper. And we saw that even doing all these application administrations of BST had an increase in follicular population. Okay, it happened, but the embryo production and the number of blastocyst produced section, it didn't increase. So the BST was not effective in this case. Again, was studied the paradoxical effects of bovine somatotropin treatment on the ovarian follicular population and in vitro embryo production of lactating buffalo donors submitted to ovum pickup. This time using two different times of ovum pickup, 7 days and 14 days, and using or not BST. And again, what was verified? That the BST treatment increased the number of follicles aspirated. The interval of OPU was better when using 14 days against 7 days. But the BST treatment did not increase the percentage of blastocysts produced per OPU. And these results, in the end, the main conclusion we had was that the use of BST did not increase the number of blastocysts produced. It increased the number of aspirated follicles, but not from blastocysts produced. So it was not we didn't had not success using this approach. And one last approach using trying to increase this embryo production was the interval between the emergence of pharmacologically synchronized ovarian follicle waves and ovule pickup could do in the embryo production. And we saw that it was not significantly affect the in vitro embryo production. We used the OPU 1, 3, or 5 days after the beginning of the wave emergence, trying to improve or to change, like I said, the approach for having better results, but it didn't work. So our last results, and I can say the better results we had until now, that I will explore better, is the use of the FSH and in the OPU in vitro embryo production in buffaloes. We know that these results are being used in bovine, in cattle, and we reproduce it in buffaloes. And what we verified? That the super stimulation prior to the ovum pickup to the OPU, it improves the in vitro embryo production in nulliparous, primiparous, and multiparous donors. I mean, it's a great technology to be used in all categories, since heifers to multiparous cows, and we had good results. We know that the success of the OPU IVP technique depends on the quantity and the oocyte quality. But we have some characteristics inherent to bubulus females. One of them is the low number of ovarian follicles, like we saw previously, and a low number of viable oocytes recovered per OPU that we also saw. And why to use the FSH for super stimulation? Because we saw in many researches that it was used with success in cattle in IVEP programs. What happened? We had greater diameter of aspirated follicles, growth of a homogeneous follicular population, and a recovery of a competence oocytes adequate for IVEP procedures. The aim, so, was to evaluate the follicular population, the oocytes, and the IVP of buffalo donors subjected to the superstimulation treatment with FSH prior to OPU. The protocol was quite simple, protocol of synchronization with progesterone and estradiol benzoate, as we can see here. We use three categories of animals to we try to make experiments using the three categories because we want to use the maximum of animals in the herd to apply the biotechnologies and in the end have great results. So it was used or not the FSH and then the OPU on day 7. So sorry, our main results was that the viable rate, the embryos per OPU, and the blastocyst rates were great when using the FSH prior to OPU for in vitro embryo production in buffalo. When we separate the results by just treatment and categories, we also can see that the viable rate, sorry, it's in Portuguese, but the viable rate here is greater for FSH treatment. The number of blastocysts as well, these blastocysts are from this study, and the blastocyst rates was also better, significantly better for the animals using FSH prior to OPU. Here for category, The number of oocytes, the number of viable oocytes were also greater for these variables in the categories. And for multiparous, for cows, it was even good, but for heifers, this is sorry in Portuguese, but for heifers was greater than cow, even greater than cows. When you compare the number of follicles, what we saw that when we do not use the FSH, the number of small follicles, the percentage of small follicles is greater, is much greater in the ovaries. But when you use the FSH, we saw that the number of medium and large follicles increased compared to control groups. So what you saw here, that in control group, we had more small follicles in the ovary, and in the super simulated or in the group that we use FSH, we had more medium and large size follicles. What does it mean? That we will probably see the ovary when doing the aspiration, just small follicles here. You can see the aspiration here. Small follicles, small follicles, small follicles. And here, you can see medium and large follicles being aspirated here. We know that there are many characteristics associated with all sides aspirated from follicles of larger size. In the end, we saw that the FSH, let's just check this out. The FSH did not increase the number of ovarian follicles, but increased the diameter and the proportion of medium follicles. These oocytes recovered from follicles with larger diameters. They have greater developmental competence when compared to oocytes from smaller follicles. That's the main characteristic. The main conclusion is that the increased proportion of medium and large diameter follicles available for the OPU procedures were fine when using FSH, and we verified also a great proportion of viable oocytes for culture that had great blastocyst rates and embryos produced per OPU IVF session. So the super simulation of FSH prior to OPU increases the efficiency of IVP in buffalo donors. Other factors affecting the OPU are the farm. This is just a recently study that we published in Knowledge for the ICAR Reunion. Pietro will present this data in Bologna, Italy. And we saw that there are, of course, like in cattle, factors that affect this efficiency. Farm is a factor. We know that there are different managements in the farms that can affect these results. The category, generally heifers present better results than cows, and the reproductive status. Of course, non-pregnant animals, because of the size and the position of the ovary and the ability to make the OPU procedure, it will be affected. So non-pregnant animals will have more oocytes recovered. Another important effect is the bull. As we see here, many sires used during IVP, we saw a great variation of the results. So since from 40% to 7%. So the effect of sires, the evaluation of the sire used is very important when applying this technology in all species, and in buffalo it's not different. So the efficiency of this technique in buffalo. If you have 10 or 9 viable oocytes recovered, considering a blastocyst yield of 30%, we have 3 embryos, and considering a conception rate of 30%, 1 pregnancy per OPU. We can increase these results? I think so, but we have to work hard to increase, and I think we are working hard to get better results, but we are on the way. Now, just to finish, I know that our time is finishing. Just few slides just to talk about the embryo transfer in buffaloes, because if we are producing embryos, of course, if we are producing embryos, we got to transfer these embryos. It's not just produce. We have to go to the end of this cycle, that is have a calf, a healthy calf in the herd. So, like I said, recently we published this article about the embryo transfer in buffalo. This is a revision article, and we talk about many of these experiments that I mentioned it. I mentioned it here, and the conception rate according to the farm in general, we have 30% of conception rate. That's why we consider this value. Based on this, we have this variation between the farms and around 30% of conception rate. Considering this conception rate, we are always working to improve our results. And we evaluated the protocols, and again, like we did in donors, here we did in the recipients. What? We evaluate the efficiency of the protocols of embryo transfer now, not embryo production, but embryo transfer in heifers, primiparous, and multiparous. And what you saw, that the follicle and the corpus luteum diameter, according to this animal category, was similar. These variables were similar, and also the conception rate and the pregnancy rate. Sorry, it's in Portuguese. The pregnancy rate here in the end, it was similar between categories. So this protocol can be used in heifers, primiparous, and multiparous with the same efficiency. This is the protocol. Basically, this is the protocol using progesterone device and estradiol benzoate. I will not talk especially about protocols today, but just to show what we are using here. And when the OPU is done in the donors, we know we have to synchronize the donors and the recipients at the same time, and all the procedures that are performed in this period. So the timed embryo transfer program, when you use 100 recipients, for example, using a utilization rate of 75, we consider 75%, we got 75 embryo transferred, and the conception rate of 30%, we got 23 pregnancies. So the efficiency of this technique in buffalo, it's about, we say, I know that this number is quite strange, 0.5 pregnancies, but we are starting from 7 viable oocytes recovery, and our we are conservative here, using a blastocyst yield and a conception rate. And what we can see is that we have a lot to do here, and we can increase and improve all of these valuables here for buffalo. The main conclusions are that the reproductive particularities of the buffalo can affect the success of assisted biotechnologies. So we have to consider all these particularities, like we said, many differences compared to Carol, but it's not something that avoids to use. And the studies demonstrate that the potential of this OPU in vitro reproduction technique to become a commercially applicable technology in buffaloes. This is exactly where we are working. We want to increase. We had a great progress in these years for this technique in buffaloes. We are applying here, but we also have a lot to work, and we hope that with the partnership of research like you in India and you in other parts of the world, we can work together and share our experiences to increase and make buffalo a great potential to explore and to develop around the world. So thank you very much for your attention. if you have any doubts now, I think now we'll open for questions.
Thank you, Dr. Julia. I just made a question in the comment box. If you can see, there are some other questions also in the comment box in the chat.
Okay, I'm checking now. Let's see, first of all. May I answer in the order or?
No, Julia, give me a few minutes, please. I just give me a few minutes.
Oh, yeah, sure.
What I was telling, you know, when we heard Professor Pietro Bruselli, that time also we said that some of our universities can have some collaboration with you in our Brazil there, as we are really, you know, the best of the Murrah buffaloes in the world are available with us. So we can do a lot of work together in buffaloes. That is number one. So with that, once again, we thank you very much for the excellent talk of yours. We will take question and answers later, but I will now request Dr. Indrajit Singh to say a few words about his rich experience into this line. And then we will request Dr. Datta. Dr. Indrajit, over to you.
Thank you, Dr. Jamar. Thank you. And thank you, Dr. Julia, for this nice presentation on embryo transfer in buffaloes, both in vivo developed embryos and in vitro produced embryos. But the story remains the same. We are not getting as good pregnancies as we can get in cattle. But still, your suggestions of using stimulation, mild stimulation with FSH and RBST, also recombinant bovine somatotropin, that gave some promise, but still we are getting 0.5 to 0.8 pregnancies per flushing, per OPU. But still, if there are elite animals and superior animals, that is adding another. What question I asked was that if with these one, say less than one pregnancy per OPU session, how often we can repeat it? If we can repeat it every, say, 7 days or 15 days, then we can get many pregnancies from same buffalo in a span of 1 year or between the two pregnancies. And ultimately, the synchronizing it with the wave emergence, your OPU and the stimulatory treatment, that can definitely yield better results. And we also hope, and as Dr. Jamar said, we look forward to working with anyone from Brazil, particularly in this aspect. Tomorrow we are having a Brazilian scientist visiting us, Eduardo Bastineto. He is visiting us tomorrow. So he will be here, another scientist in Buffalo. But although he is a parasitologist, so he will be here for 20 days. So we welcome you. We have a project in which we can invite you. And you can come here, have demonstrations, practical and lectures also to our students and faculties. And I think with Dr. Jawar, we can always look forward to such opportunity to have interaction with you on a one-to-one basis, coming and visiting here, looking at our facilities and giving your suggestions. Thank you very much for this talk.
Now I request Dr. Datta, if you can kindly put your views, sir. And
thank you very much.
Question answers here.
So first of all, Dr. Julia, it was a great talk, and where you have accumulated so many evidences. And I must say that we started with this journey back in 1986, Dr. Jawar, if you remember, in India under a science and technology project. And our initial days with buffalo was very frustrating. Frustrating in the sense that they were not behaving like that of the cows. In fact, their response to the PG and their response to the FSH stimulation and their endocrine profile also, they are very different from that of the cows. But having said that, we also worldwide have generated a lot of data. And our frustration of not being so successful with the typical superovulation embryo transfer, now it looks hopeful with the OPU IVF with doing that. But having said that, I strongly believe that the industry and the academia, they have to work hand in hand with the first basic question that buffaloes are not cows, and we have to generate the buffalo specific information. I simply give an example is that our experience, I worked a long time with genomics and all that with the buffalo oocytes and embryos, and we find the simple milestones of the embryonic development in buffalo is a lot different from that of the cows. So that probably dictates us to design the species-specific IVM protocol and the IVF protocol and the in vitro culture protocol also. So this will go a long way in terms of doing that. In Indian context, particularly, I would say that we have to find the local source of the gonadotrophins and also consumables to make this technology affordable for the masses. And we worked a lot with respect to the buffalo specific FSH, and still people are working. So hopefully it will come shortly and doing that. So having said that, it's already late evening. So thank you very much once again, Dr. Jawar, for this opportunity to share my views on this. And thank you, Dr. Julia, for the nice experience sharing. Thank you.
Thank you, sir. Julia, let me share our own experience when I was working with earlier organization, JK Trust. After coming back from Brazil, seeing it, your work over there, we immediately did that work in August 2008, September 2019. And our experience is that we just only stimulated 10 Murrah buffaloes. And with the 10 Murrah buffaloes, we got about 118 oocytes, resulted into 38 embryos. So the blastocyst rate was around 32%. And we got 8 pregnancies and the calves out of it, resulting only we got about 19% pregnancy rate. But a year later, in December 2020, we did work on Bunny buffaloes, which is a very tough breed of Gujarat. It's really, with a hot temperature right up to 45 degrees and above, it survives very well. So it was a very small number, but it was something, very excellent results we got it. We only used 3 of the Bunny donors, and from 3 Bunny donors, we got 33 oocytes. One of them gave 21, another 5, another 4. So total oocytes, we got 30 oocytes, and from which 18 embryos developed. And in one case, one of the donor, 5 oocytes were there, we got all 5 embryos. Another one with the 21 oocytes, we got 11 embryos. Like that, we got from 30 oocytes, 18 embryos with a blastocyst rate of 60%, which is a very small number. Number 3 donors is very, very insignificant number. But still, with that blastocyst rate, and we got 7 pregnancies out of it. And so pregnancy rate came to almost 47%. So even though it was a small number, I feel that the OPU, application of OPU in case of buffalo has got a great potential for taking up this work into the buffaloes on a larger scale. I have got few questions with Julia, which I will ask you once we start with the question and answer session. There are a few questions which are already there in the chat box. But before that, I would also request my colleagues who are core committee members with the made by the Government of India, if they want to put some views over here, I request Dr. Sanjeev Chaubal, who is joining us from United States, if he wants to say anything. Sanjeev, over to you.
Dr. Julia, first of all, thanks a lot for an excellent presentation. I have heard one of your other presentations also, I think last year or year before that, and listening to you is always a very rich learning experience. I have worked with buffaloes long time back, but that was mostly with the MOET technology. I haven't done any IVF work in buffaloes, but I know that in India, we have a huge buffalo population, and buffalo is the future. Right now, we are still in the process of establishing the IVF technology in cattle in India, but eventually buffalo is also going to be the direction in which we would like to go. And certainly, as Dr. Jawar sir has indicated, collaborating with people like you and Professor Barusali would be a good start. We have to learn a lot from you guys, and collaborating with you would really help us in India. I have put some questions in the question box, so I won't take much time here. But once again, thanks a lot for an excellent presentation, and it was a pleasure listening to you. Thank you.
Thank you, Sanjeev. Siddharth, would you like to add something?
Yes, so thank you, Dr. Julia. It's wonderful listening to you. Like Dr. Chaubal, I also attended the last year's talk. Being an organization in NDDU, we started working in Buffalo very recently in the IVF area. So I have very limited experience, but I would thank to you because I see my student is also there, Dr. Sanket. So we together listened to your talk last year and devised our study according to your findings. And we seen the same way you are saying that with CIDAR and FSH, they are giving excellent result. Mura buffaloes in India, we worked in Bunny and Mura. Both are working in similar way. We are getting around 2.6. We did not very high number of OPUs. We did something around 30 OPUs, and it is giving around 2.6 embryos per OPU and around 10 to 11 oocytes per OPU. And while there is no difference between stimulated and unstimulated in terms of oocyte recovery, we are getting in both of them around 10 to 12 oocytes. But in unstimulated, the embryo production, it is very low. It's something around 1.2, something like that. It's coming. So there is a huge difference, like almost 1.5 embryos more we are getting in stimulated. But we definitely look forward to collaborate with you down the line. I'll get you in touch with you. Thank you. Thank you, sir.
Thank you, Siddharth. Julia, before we move to the question answers, I have got few questions which I would like to know from you. You know, when we are stimulating with the buffaloes in your article, and which we exactly followed it, the faltropin dose, the FSH, which was divided into 4 doses. I wanted to know what is the reason of dividing dose in this way, that first dose is of 2.85 ml, then another 2.85 ml, and then 2.15 and 2.15. So the total dose is 10 ml. Is there any specific reason of going into these decimal, but we followed it exactly? This is my question number 1. Second thing, Julia, which I have observed is that, when we did with the bunny buffaloes, somehow our flights were missed and all that, and we were carrying these oocytes into the microQ incubator using the IVM HIPS media. And then ultimately we were worried and we reached our IVF was delayed by 5 hours. Even then, as I said, we got 60% blastocyst rate. I don't know. Then I immediately referred the literature, and then I could notice that even if IVF delayed even right up to 30 hours also, you may get results. Now, third point is in India, unfortunately, we are not able to get this PMSG polygon or that ECG, stimulate the pregnant mare serum, which really helps in the recipient synchronization very, very well. My fourth point is that in your protocols, you have been using estradiol cyponiate. Why this estradiol cyponiate is being used into the synchronization protocol? So these are a few of the questions from my end. Once and thereafter, we can start the others in the chat box, please. Over to you, Julia.
Okay, thank you. Thank you very much, everybody, for the questions. Probably I will ask again because I want to remember all of them, but let me try. The first one was from Dr. Indrajit, right? And I saw that here in the box. He asked about the interval between the OPU sessions and Buffalo. The interval we are using is 14 days. Now it's the better interval that we are using. Some vets, they like to use 7 days, but I'm not sure about the 7 days yet because of the damage in the ovaries. It's not the technique. Mainly, I always say that it is associated about the quality of the aspiration process. But even with a great aspiration process, I think that 14 days we got bad results because of the recovery of the ovary and the damage in the ovaries and the time for buffaloes to recover from the OPU procedure. I'm not saying that the OPU procedure needs a recovery and the disease will be damaged for the animal. Just saying that in our experience, 14 days is the better. And how many sessions recommended between two pregnancies? The sessions between pregnancies, they start to become hard, of course, when the pregnancy is advanced, because of course the anatomy of the animal. So it depends a lot on the practical ability of the technique. In Brazil, we always say it, even for cattle, there are many vets doing aspiration, and sometimes the quality of these aspirations, they make this technique for the producers, they don't see with good eyes. They say that OPU is bad for animals, but it's not. The way how the technique is applied, that is bad. So it will depend on the ability of the technique to do that. I don't know if I remember the following question. I think it was about the I don't remember, but I think it was
You can refer the chat box, Julia, and do the rest of the questions.
Okay, I think it's better. What kind of synchrony between IVF and recipient heat is preferred for buffaloes? Is the one that we showed in the slide, is the preferred one. I think the presentation is saved, right? So we can check there. We also share our protocols. We don't have problems with it. So that is the best protocols that we use. I think that I can answer now one of the questions of Dr. Shim, that was about the use of estradiol cypionate in the protocol for recipients, right? Was that?
Yes, right.
The estradiol cypionate is one of the best estradiol pharmacs or drugs that we use for synchronizing the ovulation, mainly because of the ovulation. The use of estradiol is a cheaper drug when we compare cypionate, when you compare to estradiol or GnRH or other drugs that we can use in the protocols. And the synchronization of the wave, the synchronization of the ovulation is very good. So that's why we use the estradiol. And based, of course, in other protocols that we developed, they use it, the cypionate for timed artificial insemination as well. So we did the dynamics and all of these evaluations. So that's why we use estradiol in this protocol for recipients. The other question is about the different breeds of buffalo in Brazil, Dr. Chabal. And I think, I don't know it's correct, Chabal, right?
Chobal.
Chobal, sorry,
Yeah.
Chobal. And the different breeds are, we have mainly 4 breeds in Brazil. We got Murra, we got Jafarabad, we got Mediterranean, and we got the Carvalho. The main difference are in the horns, but the mainly Murra and Mediterranean. Mainly, but most of our herd is Murra. And do you see difference in their performance? Mainly the studies were performed in Murra and Mediterranean, so we don't have many data in Jafarabad or Carvalho. But the few studies we have, they show that we don't see too many difference between the performance between these breeds. Is it day 6 or day 6 and day 7? We are doing around 22 hours maturation for IVF of cattle. Would buffalo require some time for IVM steps? Especially day 6. And I think Dr. Zauer told something about it, that you didn't saw a difference, right? in the use of this maturation. I don't remember if it was you, doctor.
Yeah.
Yeah, many things are similar to cattle. Many things are still similar in the lab. So day 6 and 22 hours maturation is, I think your results could be good using this time. Any difference in incubator temperatures and gas? No. As I know, it's this. I'm not working directly in the lab, inside the lab. Like for example, Yeda does. She has a lab and she works inside the lab. But as according to my knowledge, it's the same temperature. It's the same, and cases percentage are also the same from cattle. The part I have to say that this part of the lab for buffalo, it's a field that we have a lot to work as well, because we always use based on bovine, but we can develop many different approaches for buffalo, especially because of we know the quality and the type of some, for example, cells of the buffalo in the development in vitro are different from cattle. So the media and other characteristics we probably have to change or can change to improve the in vitro embryo production. Percentage. Okay. About Dr. Chabot again. It's a very good question. Is sexed semen available for buffaloes? And how many sessions recommended between two? And what works better? And if yes, what is the embryo development rate in IVF? Yes, sexed semen is available for buffaloes in Brazil. We did few experiments, but I have to be honest, like always, when you're doing research, our results here in Brazil with sexed semen were terrible. We didn't achieve any pregnancy, any pregnancy of this semen. And in the end, the evaluation of the semen, we saw that the quality of the semen was not very good. So the technique performed for sexed semen in buffalo in Brazil, I think that we have a lot of challenge to go to make it possible and to make the results better. But yes, it's available. We know that not in research, but in the field, in commercial applications, they are using, but the results are not very good yet. And let's see the next one. What should be? I saw. I will answer it. What's experiment with frozen embryos? Okay, frozen embryos. I don't have too many experience with frozen embryos in buffaloes, but I think probably like bovine, you always compare it with cattle. Even of course we know that it's different, but I think that will be good. But the problem with frozen, I think it's the logistic for doing that, and we try to work in a way that will be better, that will be easier of application of this technique, and maybe using freezing or vitrification, it will, or direct transfer that we are using here now as well. We are using a lot direct transfer, will be better to be applied in the field. But I'm not excluding, of course, the frozen embryos, but I don't have too much experience. And the few I know is that it's okay, but we don't have a large number of animals evaluated to say something with more accurate. And at least last here in the box, I think this one, is there any more increase in oocyte quality if dose of FSH is increased? Ideal coasting period for buffaloes? Great question. I would like to know that. This is an experiment to do. I invite you in collaboration or not, if you want to try just in your research group, Dr. Patil, should try this. I think it's very interesting. Maybe it works. I will also talk about one of the questions of Dr. Shem, that was the doses of FSH, right?
Yes, yes.
Why that doses?
Why it was
That
so?
doses, yeah. Even when we wrote the paper, the
Yeah,
manuscript, we had difficult to write this, to explain to the reviewers from
yeah.
theriogenology, because they didn't understand why. And we just resume, we just used the same from cattle. The same used from cattle. We just would like to repeat the same pattern, because they use the same pattern of release of the FSH, because it's the literature, the report shows that it's necessary to be first of all a great peak of FSH, and then is in small proportions. So that's why we use that that percentage of releasing, just based in both mine papers and in the literature. But using different approach, for example, doing an experiment using 200 or 300 milligrams and different ways of releasing, we can check that. Probably it will work as well, but we don't know in the molecular dynamics how it will occurs. But we can try, we can check it. It will be interesting.
Yeah, Julia, this 200 milligrams, no, which was divided into, as I said, 2.85, 2.85, 2.15. It was making very tricky. So ultimately, we did it 3 ml, 3 ml, and 2 ml, and 2
I
ml
agree. I agree. I completely agree.
to make it more.
When we recommend, when we recommend it, people always say, "How can you repeat, please? I did not understand." I agree with you. I agree.
Right. And another thing which I wanted to ask you, as I told you with our experiment with the bunny, the IVF got delayed to 30 hours. So what's your views on that? I mean, because of some reasons, we could not reach our lab. And even then we got a good blastocyst rate. So what are your comments on this? Extending the IVF timing, which normally should happen between 22 to 23 hours. It was delayed by 5 hours. Still, we got a good results.
Yeah, I think that let me see if I understand. If I understood, you are saying that you are having a similar time to cattle about the developing of the blastocysts, right?
No, no, no.
That you don't need to evaluate earlier. Is
No,
that?
no, no. My question is, see, normally when you carry the oocytes for maturation, you put into the IVM media and you put for IVF after 22 to 23 hours. But because of some reason, it got delayed by 5 hours. We could not do IVF. So still we got good results. Even after after that. Why?
Delayed. You are talking about delayed.
Yes,
Yeah,
yes.
because in buffalo it's commonly to be the opposite. It's faster. It's the development is faster in buffalo, not delayed compared to cattle. Like I said in previously, in buffalo we are used to use the same procedures from cattle, but we don't know exactly how buffaloes, oocytes, and embryos they develop in the media, especially for buffalo. We don't have, for example, a culture media especially for buffalo, like we have for other species. We are using from bovine. So I always say that we have a lot to check, that we have a lot to test, that we have many experiments, many experiments to do to evaluate this. I think probably this question that we are talking about is the same is similar from something that I think Shabal talked about, that we did not see difference using FSH or not using FSH. I think was that Dr. Shabal?
No, he
Something
was
like
Dr. Siddharth. Yeah, Dr. Siddharth was telling.
Dr. Siddharth, exactly. They didn't see difference. I think this is associated. Is it in India? This result?
Yeah, India.
Yes,
Both,
yes.
both in India, right? I always say that you in India, you got a great power in your hands. Why I am saying? Because your herd, you got the best herd in the world. I'm talking about buffalo herd. Your genetics is very good. When we talk about genetics, about selection of donors, we got it. When we got donors selected, the better donors, if you think well, they don't need treatments to improve because they are good donors. They got a genetic that produce a great follicular population. And with a great follicular population, you will achieve more oocytes and proportionally you will have more embryos produced. So that's, I think, why in India sometimes we don't see this difference because we have many good animals. And when these good animals, they enter in the studies, the genetics of these animals is superior. So the production will be better. So you have this variable. That's why, of course, in our studies, in research, we select the animals, we control the groups, we control the animals in each group, of course, in experimental design. But even though there are animals with great merits, great genetic merits, and this is very important when applying biotechnologies, especially in India. You got great animals, and you can do the selection of these animals, these donors, especially.
Thank you very much, Julia. And before we conclude it, I want to just add two things. I don't know whether, have you heard about black gold, Julia? Have you heard about black gold? Black gold.
Black gold, I'm not sure.
You're not heard. We have been talking for the last 1.5 hours. We call in India buffalo as the black gold.
Oh yeah, black gold. I understood another thing. Black gold, yes. Here in Brazil as well, we say black pearls.
Okay.
Black pearls.
And then another thing is that we have a wonderful experience when I was with earlier organization about a decade ago. We arrange a Murran ramp. We walked one of the top buffaloes in one of the state, Haryana state. They were walked over a ramp like a model snow. They walk over the ramp. We organized the best buffaloes to walk on the ramp, and then they were given the best of the prizes. Just to say about that. With that, I once again, on behalf of Bovine Embryo Transfer Group and me representing Government of India, thank you very much for your time. And further, I also thank our Vice Chancellor of the Gadwasu University, Dr. Indrajit Singh Ji, and Dr. Datta for sparing their valuable time. And I also thank all the members of the Bovine Embryo Transfer Group and other participants who have joined from various corners, and some of them have joined on the Facebook Live. So I thank each one of you, and thank you once again, Julia. And with this, we look forward for some collaboration with you and your university, South Paul University. And with this, I wish you a good day ahead, and thank you very much. And I declare this session as closed. Thanks a lot, and namaste. In Indian way, we greet namaste. Thank you.
Namaste.
Thank you very much.